since it's a regular pentagon, we know how to find each angle. We do. We have a formula for that. There's an app for that. There's a formula for that, right? So the formula is n minus 2 times 180 divided by n. It's 3 times 180 divided by 5. You know how to find the angles of any regular polygon that we give you. So when you do that formula, you're going to get 108. 108. Each angle, the whole angle, is 108. Here's the cool part that I like. Now we're going to look at triangles. We're going to go from polygon to triangle. A triangle is a type of polygon. If you look at this triangle right here, we know something about that triangle. We had to use our prior knowledge in our brain to realize, wait, if this is a regular pentagon, then all sides are congruent. Tick mark, tick mark. Well, if that triangle has 2 tick marks, it's an isosceles triangle. Very good. We know that in an isosceles triangle, the base angles are congruent. We learned that on Monday. The base angles are congruent. So y and that other angle, they're the same measure. So 180 minus 108, and then divided by 2. So these angles are 36. 36, 36. I could do the same process on the other side, on the right side. 36, 36. I know that angle D, I know the whole angle is 108. So if I do 108 minus 36 minus 36, I get 36. So that angle was actually trisected. Is that a word? Bisected is a word. I'm not sure if trisected is a word. Cut into 3. We couldn't assume that from the beginning. Maybe we could because it was regular. But we use other pieces to show that it really was trisected. Well, now it is. Now it's a word. Okay, so 36 was the answer to those. Let's look over here at this one. In this one, I would start with that 30-degree angle and the fact that the triangle is isosceles. So if that's 30, then that's 30. Ooh, that triangle is not isosceles. It's more than that. We just offended him by calling him isosceles. It has double tick mark, double tick mark, double tick mark. This is the key to the problem. That's not isosceles. That's equilateral, equal angular. That means every angle is 60. 60, 60, 60. And this problem just got easy. So 60 minus 30, that means this is 30, 30. And now we can find y. If we've got a triangle and this is 30 and this is 30, we can all find the missing angle. So 180 minus 60. 120. All right. Next problem, number 12. If JL is 5, then ML is... Now, we're going to have more tools to solve this problem today, but if you just used your best guess, which you're not really supposed to assume, right? You're not supposed to assume. But because this is isosceles and because that's an angle bisector, it actually does cut 5 in half. So this problem is just 5 divided by 2. It's 2.5, and I can show you other reasons today why that's true. Okay, last one, 18. Okay, let's get this one. In triangle ABC, A is congruent to C. So the first thing you're doing is you are drawing a picture. Every student is drawing a picture. A, B, C, where A is congruent to C. If AB is 4x minus 6, BC is 3x plus 24, and AC is 3x minus 15, find the length of AC. This is a classic, we gave you too much information, don't you dare use it all problem. That's what it's called, officially. No. In this problem, you're not going to use all 3 of those. You're going to use the ones that matter. You're going to use the legs. The legs are always across from the base angles. The legs in an isosceles triangle are congruent. So we know that 4x minus 6 equals 3x plus 24. We know that x equals 30. So we did not use the 3x minus 15 yet. We ignored it. The base cannot help us find the legs. So now that we found x, all we do is plug it in, 3 times 30 minus 15, and boom, we have the length of AC. So instead of x here, you're going to put 30. Oops. And now that problem's over. So the key to that problem was not trying